Alright guys, so we are going to solve quadratics by factoring. So let's review a little bit about kind of what we already have done. So last week we were working with complex numbers, but we did talk about how to multiply binomials. So if I gave you x plus 2 times x plus 3, so these are two binomials because they have two terms in each, right? I used that distributive property twice to multiply these together. So I'd multiply x times x, which is very good, and then x times 3, which is, so plus 3x since it's positive. And then I did the same thing with the 2. I distributed it to the x, so 2 times x is 2x, and then 2 times 3 is positive 6. And then I had those like terms in the middle here, correct? So that gives me x squared plus 5x plus 6. Okay, so we did a couple of those last week, except we were messing around with the I with the complex numbers. So when we had I, it was a little different because we had our last term would be like I squared, and then I squared was -1, so then we'd have to multiply, and we'd end up with 2 terms, not 3 like here. So today we're going to be solving quadratics. So this is where we're going to start today. It will say equal 0. But we're going to we're solving by factoring, so we're going to work backwards. This is where start, and this is where we're going to finish. So we're going to go back to the binomials, the two binomials, okay? Factoring is multiplying. So what's the opposite of multiplying? I mean, not factoring, sorry. You're multiplying. Dividing is the opposite. So basically factoring is like dividing, okay, for polynomials. So if I were to graph this, my graph would be over here. Basically, this is telling me my x-intercepts when I solve, okay? When I solve this, I know you see positive 2 and positive 3, but you'll see how really that when I graph this polynomial, even if I wrote it in the calculator exactly how you see it here, either way, if I put in the graphing calculator like this as a polynomial or two binomials, it would give me the exact same graph, and the x-intercepts would be at -3, -2, and you're going to see why today when we solve, okay? Alright, so our notes. Sorry, I'm going to get another pen. There we go. So first of all, before we start solving, let's talk about factoring. Let's review. This is something you did in Algebra 1, but that was a long time ago, wasn't it? And you didn't do this in geometry. You didn't have to factor. So when we factor polynomials, and all of our polynomials, we're really lucky, are going to have a leading coefficient of 1, meaning if you look at every single quadratic function, it begins with x squared. Well, what's the coefficient of just x squared? It's 1. Coefficient is a number, okay? It's the number being multiplied to a variable. That's what a coefficient is. So when it says a leading coefficient of 1, it means every single one of these problems starts with 1. You just don't see it. Alright, so how to factor. We find factors. Let me zoom in a little bit more so you can see this better. Find factors of the last term that add up to the middle term. And you might be saying, well, what about the first term, Miss Sullivan? That one's easy. I'll show you that in a minute. So the hardest part of factoring is finding factors of the last term. So last term, like on the first example, would be 8 that add up to the middle term, which is 6. Okay? So how do we start factoring? Well, when we have a leading coefficient of 1, we just start factoring by our parentheses. Just drawing or writing out our 2 sets of parentheses. Both are going to start with what? X. Because when I remember when I multiplied earlier, x times x gave me that x squared, didn't it?
Oh, so you're basically doing all this in reverse.
Exactly. That's what I was saying. See, right here. So we're going backwards. We're going that way. So they're all gonna start with x, okay? Because our leading coefficient is 1. All of our factors will start with x. Got it? Now here comes the harder part. So we are gonna look for factors of 8 that add up to 6. So what I do, I like to put it over here. So here I'm looking for factors of 8 that add up to 6. So I can write all my factors of 8. I always start with 1. 1 times 8 gives me 8. 2 times 4 gives me 8. I'm pretty much done at that point, right, with the factors of 8? Which set adds up to 6? 2 and 4. That's what I'm going to put here and here. 2 and 4. And it doesn't matter which order. I could put plus 4 plus 2 or plus 2 plus 4. It doesn't matter how I write it or which order I put it in. And there's my factors. Now it's easy when it's all positive. I can just tell you that. It gets a little tricky when we get to the second one and we have negatives, but it's not too bad. All right.
When putting it into the pieces, you basically look at the 6x and the 8 to figure out.
Yes, what to put here. So I'm looking for, like I said here, I'm here factors of the last term that add up to the middle. That's what I did. I looked at factors for 8 that added up to 6. Does that make sense?
Yeah.
Okay. This only happens, it's only this easy when your leading coefficient is 1. So my leading coefficient, that's a 1 right here that you don't have to see. Does that make sense? You know, guys, coefficients are numbers that are multiplied to variables. So like the coefficient of x is what? What's the coefficient of just x?
1.
No. Of x. 6. Now the coefficient of x squared is 1. But the coefficient of x is 6. Got it? Okay. So here, again, I'm going to start with my 2 sets of parentheses. They both start with what? And it's only because our leading coefficient is 1. Now, this time we're looking for factors of negative 12 that add up to, what's my middle term this time? It can never be a variable, guys, so don't tell me x. Negative 1. Okay? So this is a little different, and I like to use, I'm going to use my piece of paper here. So I'm looking at factors of negative 12 that adds up to negative 1. So let's not worry about the negatives right now. Let's just write down out the factors of 12, starting with 1 and 12. What would the next ones be? 2 and 6, 3 and 4, and we're done, right? There's no more after that. I mean, it could be 6 and 2, but you'll start repeating. So all of these give me, if I multiply them, give me positive 12, correct? Mm-hmm. So I have a negative 12. That has to add up to a negative 1.
So should we turn all negative?
If they go all negatives, a negative times a negative would give you a positive 12. Only one has to be negative. But think about this. It has to add up to a negative, so we have to remember the rules of adding integers. If you add a positive and a negative together, the answer takes the sign of the bigger number. So since our answer is negative and it's got to take the sign of the bigger number, we're going to make all our bigger numbers negative. Got it? So now if we start adding them together, which one adds up to negative 1?
3 and 4.
That's right, 3 and negative 4. So this is positive 3, so I'm going to put plus 3. This is negative 4, I'll put minus 4. So see how negatives can be just a little bit more, a little harder? Yeah. All right, everybody have this down. I know there's not room on the paper to really put it. If you can find some room like at the top or something to put this, that'd be good.
And you have to put like a factor of...
I'm writing this down so you know what I'm thinking, so you know how we got this. You don't have to write this down every time. That's a good question. This is just so you know this is what your thought process is every single time, okay? All right, so starting with our two sets of parentheses, both starting with x. This time we're looking for factors of
7 that equal
add
to 8.
up to negative 8. Very good. So this time we have, this is a good situation because 7 is what kind of number?
Prime.
It's prime. So there's only two factors for 7, which is 1 and 7, right? But it has to add up to a negative 8. So what? Make only the 7 negative? Both of them, because it has to multiply to give us a positive 7. So if I left it like this equals negative 7 when I multiply, right? But if I make them both negative, negative 1 times negative 7 gives me positive 7, but a negative 1 plus negative 7 equals a negative 8. So we had to make them both negative. So I'm going to have you do these next 3 on your own. But look at number 3. Review number 3. It says x squared minus 25. So tell me something. I'm going to write it down here. We are looking for factors of, what are we looking for? Factors of
25.
Negative 25 that add up to 0.
Oh, yeah, because it's missing that x.
Because it doesn't have that middle term, right? So it doesn't have x. X is always our middle term. All right, so I'm going to give you about 4 minutes to do this. If you need help, let me know. If you don't have your notes, this is a good one because you just write down each problem. It's not that difficult.
Not right now. You can ask come here before school, or you can ask someone again. Okay. Yeah, we'll talk about it.
Ooh, this is a challenge.
I think so. Probably not. I'll try to get that a little bit better clear too. It's not
Let's see if we break it down. The biggest one is 3 and 5. Let's get 25 times 2.
It's going to be similar to this one. Because as the multiply to give you a positive, but add up to a negative, right? That's what the third one, I had to do the same thing with that third one. I'm going to put something like that on my table.
Oh, wait.
No.
Wait, wouldn't that
Yeah.
the bigger number?
Alright, so guys, I'm going to put some instructions on how you can find factors. Because if finding factors are giving you a hard time, I want to eliminate that. So, you can write this down.
Makes sense.
To find factors of a number on the calculator, this is how you do it, okay guys? To find factors of a number on a calculator, bless you, you're going to go to y equals, then you're going to type in the number and divide it by x, hit second, bless you, and graph. So what does that look like? So what factors are we trying to look up on review number 1? Factors of negative 15 that add up to 2. So on the calculator, I go to y equals, I type in negative 15 divided by x. Y'all see that? And then I'm going to hit second graph, and it gives me all the factors of negative 15. So we're looking for the two factors that add to a positive 2. So I know it's not going to be, let's see, a positive 2. Negative 5 and 3 gives me negative 2. Negative 3 and positive 5 give me oh, so I found my factors, didn't I? Do y'all like that on the calculator? Yeah, you can do it that way. Yeah, you can mix it. It doesn't have to be in that order. It doesn't have to be negative 3, 5. But it could be 5 and negative 3. Okay, so my factors here could be positive 5, x plus 5, x minus 3, or it could be x minus 3, x plus 5. Got it, guys? So it doesn't matter the order. So I'll let you do the rest since I showed you that. That's okay. I mean, like, it shows you.
It says negative 5.
Yeah. Well, you don't want that, though, because negative 5 positive 3 equals a negative 2. So go down to negative 3. Negative 3 and a positive 5. That gives you positive 2. Okay. So see if that helps you guys out.
Basically, the two factors have to count each other.
I'll be doing as soon as possible, okay, because I'm getting other stuff, so if I didn't move those.
Square root of what's the number
I know.
that you get? Basically, 5 times 5 is 5. 5, positive 5, negative 5. Because then they counteract each other and they become 0.
Better?
Is that really important in terms of that on the calculator?
Oh, I have to do
Which song do you think we did best on?
I was all about the Mountain Dew and Dr. Pepper. There you go. So these are factors.
20 starting 9 at the end. I well, tenors go all the way up and all the way back down on one piece. And I thought that that's when we were hitting. I went instead of down at the very end. Probably not.
Or negative 9, yeah. So that's, there you go. So you
So did you
It's better for you than soda and a lot of sugar.
count me my favorites from the concerts?
So like,
Oh, really?
so here, hold on.
They should be better at singing.
Yeah, I know that's a little confusing.
I mean, yeah, when you're in the and when you watch them, you don't realize how much you don't pronounce your words until you see like a younger choir screw up.
Oh, you don't use it as much.
Strickland did pretty well. But then again, I was backstage right next to
Probably have to memorize more.
and sing.
Yeah.
To me, it sounded completely different.
Do we start solving the other one?
No, don't. That looks good. Yes. All right, I'm going to put the answers up so you can see what you're supposed to get. So and most of you are getting them, so you're doing a great job, by the way. So on number 2, you would get x, and it doesn't matter the order here, so it'd be x either minus 4 times x minus 5. So it could be the other way around, x minus 5, x minus 4, okay? The last one, x plus 5, x minus 5. What kind of number is 25? Perfect square. What kind of, is x squared a perfect square as well?
Yes.
So these are called the difference of squares. Because we're subtracting 2 perfect squares. That's why they're called the difference of squares. And this is the pattern you'll always see. If you have x squared minus a perfect square, this is always what you're going to see. X plus the square root of that number, x minus the square root of that number. Because isn't the square root of 25 5?
Yeah.
That's why you got those 5s there.
Does it matter if I put x
Minus.
5 first? No.
Not at all. That's called a commutative property of multiplication, so it doesn't matter your order. So you're allowed to do that. Like I'm allowed to say 2 times 3, because that's 6, or 3 times 2, that's also 6. So it doesn't matter which way I multiply it. I can't do it for adding, I can't do it for subtracting or division. It does matter the order in subtracting and division. Okay?
And adding 2?
Huh?
In adding 2?
Adding, you can, it doesn't matter the order in your adding, right? Because if you add 2 plus 4, that's 6, or 4 plus 2, that's still 6. So it doesn't matter the order. That's the commutative property. Okay. So now, what you see with our next examples, what's different?
It has an equal.
It has an equal sign. If it has an equal sign, that means you're solving. Okay? Listen to me again. If it has an equal sign, that means you're doing what? Solving. So I have a lot of people that are looking at things like this, and then they start factoring, but they forget to solve. So we're combining the two. We're going to factor to solve these quadratics. We are looking for our x-intercepts / our solutions / zeros of our functions are the root of our functions, okay? Those words we've used many times over and over in this class so far. I'm going to write down first the steps to take to solve, okay? So our first step is you have to make sure the right side is equal to 0. Because if you look at example 2, is the right-hand side equal to 0? No. So that's always our first step. Step 2.
I don't have 2 answers.
Step 2, we have to factor the left side. Step 3, we're going to set each factor equal to 0. And step 4, you're going to solve both equations. These are the steps that you need to take in order to solve quadratic functions using factoring. So, I'm going to give you a second to finish copying this down, because I'm going to put a little sticky on top so I can actually solve this problem, okay? Because I ran out of room. If you ran out of room, then you can get another sheet of paper out, or use, well, no, not the back of your packet. You can use the bottom. You can probably use the bottom of this paper to solve it. But you really need these. These will help you on all 5 of these examples, okay? You ready? And I'll uncover this, so if you don't finish, you can look. Alright, so first we have to make sure that the right-hand side of the equation is equal to 0. Check, right? Number 1 is check. So we don't have to do anything. Number 2, factor the left-hand side. So I'm going to factor this left-hand side by, like we did above. But we have to make sure it still equals 0, okay? So, of course, draw my 2 sets of parentheses. Both start with x, but we're looking for factors of negative 12. That adds up to positive 4. So we have 1. So 1 and 12, 2 and 6, and 3 and 4. Which one's going to be negative? The smaller numbers or bigger numbers? Well, remember, it has to add up to a positive 4. So it's going to be our smaller numbers are going to be negative.
So
It's going to be 3 and 2. I believe it's going to be 4, right? Oh, wait, no, 2 and 6.
it's going to be 6 and 2, yeah.
Yes, it's going to be 6 and negative 2.
I thought it was 1. Okay, that's a little issue.
Because it has to add up to a positive 4. So remember, when you add a negative and a positive together, the answer always takes the sign of the bigger number. So my bigger number in this case had to be positive since it had to equal a positive, okay? And then plus 6. There we go. So we have factored. So we've done step 1 and 2. Now step 3 says set each factor equal to 0. So I need to take each one of these. So x minus 2, set it equal to 0.
And then x plus 6.
And then x plus 6 equal to 0. Because think about what we did the other day. Didn't we have to have 2 answers for our solutions? Same with this.
But then we have to find the final answer.
Yeah, so now we have to solve step 4, solve each equation. So that means solve for x. So I'm going to add 2 to both sides here. And we have x equals positive 2.
Yeah, the other one was a negative 6.
So y'all get it. That's how it's going to be every single time. Okay, so you kind of get the, you don't have to show this step every single time. But just in case you need to see it right now.
X equals negative 6.
And these are your solutions. These are your x-intercepts for this graph. Okay. Any question? Got it? So we're just adding a little bit more. Now here comes the complicated part. What if it doesn't equal 0? Does everybody have this written down?
Yeah.
Okay, so I'm going
Like
to...
the other one?
Those things, no.
Oh, no, I was talking about the paper. But here, I'll go out a little bit so you can see that while I'm working this problem. All right, so like I said before, we're looking at example 2. Our first step is to make sure the right-hand side equals 0. Well, is that true for this one?
No.
No. Guys, we need to move the terms, the 2 terms, x and negative 21, over to the left-hand side. When we move terms, you're only adding or subtracting. There's no multiplying, there's no dividing.
Like solving for y.
Kind of, yeah. It's like you're just moving those terms over, and you do only move terms by adding or subtracting. Got it? Okay. Now that we know that, so I'm going to rewrite this. All right. So let's just start with the x first. This is 1x. So how do I undo? How do I move it over to the other side?
It's going to be negative.
It's going to be negative 1x, right? So if I'm subtracting x from this side, then I'm subtracting it from the other side. And I'm going to put it underneath the negative 9x because those are like terms, right? I can combine those together. So my x squared comes down. Negative 9x minus x is negative 10x. Equals, my x is canceled out, and I'm going to bring down negative 21. I'm writing too big already. I'm going to run out of room. Okay, so now I need to move my negative 21 to the other side. So how do I undo that? I'm going to add. Now 21 doesn't have a like term over here, does it?
No, so it should be.
I'm just going to put 21. Whoops.
Just adding it to the end.
And because it's a quadratic or polynomial, the term without an x always goes at the end, okay? So I'm going to have x squared minus 10x plus 21 equals 0. Even though these cancels out, because there's nothing left on the right-hand side, I have to put 0. And that's what we wanted, right?
Yeah.
That's only step 1. Now we need to factor and solve, okay?
So it doesn't like normal.
Now it's like normal.
Should be like.
So we draw our 2 sets of parentheses, both starting with x.
Yeah.
We're looking for factors of
Wait.
21 that adds up to
Negative 10.
negative 10. So factors of 21 are 1 and 21, 3 and 7, and that's it. And they all have, because they have to add up to a negative but multiply to a positive, they're all going to be negatives.
So we're going to use the 3 and 7.
That's right. Negative 3, negative 7.
So the answer will be 3 and 7 positive.
So I'm going to set them each equal. X minus 3 equals 0. And x minus 7 equals 0. X is going to equal 3. And x is going to equal 7. Those are my solutions. Did I lose anybody on that?
Wasn't too hard.
Mm-mm. If you get the factoring, the solving's easy. And this part could be a little complicated, like to understand how we're moving things over to the left-hand side. So I want you to go ahead and do these 3 problems, okay? And then I'm going to come around and help you guys out.
So like, now we work her, so that's squared, so 2x is right. So like, if I want to put this into the calculator,
Do the center one
and then plus 4x.
Have you already started? Ooh.
So that's why
That's easy.
because look 0. Do you see what the is? So we're looking at 0. So we're looking for the x-intercepts. And because any point on the x-axis, the y value is 0. Okay. So does that, are you putting that together now? Yeah. I need to go over that because I didn't go over that with all my other classes.
No.
Yes, so what's going to happen? Well, how do you have to subtract because all of this likes the equation, right? Or just, you don't usually just cancel out. Which looks a little bit equals 0, of course.
It's really easy to skip the last step. So all you're doing is just from positive to negative, negative to positive. It's surprisingly very easy.
So these are all the factors of 12.
But you did it.
So go up and make this. So what you said.
Okay, I did not mean to write it that way. I wrote x equals -2 by accident.
Add up, so like, it was -5.
Oh, okay. Yeah, going across, sorry.
Well, how much was the add these up in my head? Write it down,
Still in time.
write all of them down, and then add it up on the calculator, see which one. So that's what you're just gonna have to get a little extra step, see where it's, so you can start with breaking it down into 12.
This is the opposite.
Can you see this what you're putting here? Because your next 4 is the same as negative 14.
Yeah, it is the last thing. Yeah, I have to do it if you want to do it as long as I understand it. It's really not all that hard. The test this period of this quarter will be easy.
Now, tell me something. Does 1 minus 16, does that equal 0? And so you look at the factors of negative 16, that equals 0. So, it's like, you gotta factor out like you did this one. So you see how there's the same number, but when you're adding and subtracting, and you're gonna add those together, they equal 0, but when I multiply them, equal negative 25. Yeah. Because you're still, remember, you're adding, you're deciding factor. So the last one that adds to the middle. Remember, our middle now is 0 for this one. Just like the middle is 0 for that one.
Why do you
there you go.
Alright, so a lot of you are done. Let me put down what you should have gotten. So here I would have gotten x minus 2 times x minus 6. Whoops, there you go. So here are my solutions for the example 3. Example 4, I had to bring that 6x over to the left, right? So I have to subtract 6x from both sides. Well, that gave me x squared minus 16 equals 0. Is everybody in agreement with that? Because you had to subtract 6x from both sides, the 6x. So what does this 6x, the like term on the left-hand side, what does it go with? Positive 6x, right? So minus 6x. So if I subtract 6x from this 6x, don't they cancel out? And that's why I just got x squared minus 16. This looks a lot like this problem here where I had x squared minus 25, right? So I'm looking for opposites that multiply to give me negative 16. You should have gotten x minus 4, x plus 4. Yeah. So your x minus 4 equals 0, x plus 4 equals 0, x is going to equal positive 4, and x is going to equal a negative 4. And there's the solutions. And the last one, I'm going to subtract 2x from negative 3x. So that gives me x squared minus 5x minus 6 equals 0. Factors of negative 6 that add up to negative 5 is going to be negative 6 and positive 1. Y'all agree? What's negative 6 plus 1? Negative 5. Negative 6 times 1 gives me negative 6. Okay? So x minus 6 equals 0. X plus 1 equals 0. X equals 6. And x equals negative 1.
Would negative 2 and negative 3 work as well?
No, because a negative 2 times a negative 3 would give you positive 6. It does add up to negative 5, but it multiplies you to give a positive 6. That's why it doesn't work. Okay, guys. So I had somebody go, like, sometimes it just can't. Some of you just take it, what I say, and you just take it, go with it, you're fine. You don't need any other explanation of what's going on. You're just like, I just want to mindlessly go through this. But there is a connection to what we're doing. Let's take this problem here, example 3. Why are we getting 2 answers for x? Why? Why are we getting 2 answers for x? Put your phones down and you look at me. Why are we getting 2 answers for x?
Because we're factoring.
Okay. But
Because the parabola crosses over x.
the parabola does what?
Goes over x.
The parabola crosses through x twice. Okay, so this is my equation. If I were to go to my calculator and go to y equals, well, first of all, do I see y in this equation at all?
No.
No. Instead of y, what do I have?
0.
A 0. And on the x-axis, any point on the x-axis, what is my y value? Any point on the x-axis, what is my y value? 0. Hence, is equals 0. So if I type in x squared minus 8x plus 12, and I hit graph. First of all, I'm going to hit zoom 6 so you can see it better.
How come my answer?
Look here. If I hit trace, where is my, there it is, okay. So if I hit trace and if I, let me see, 2. Look, when x is 2, y is 0. And look here, it's on the x-axis. It's my x-intercept. And then I got x equals 6. So if I type in 6, enter, x equals 6, y equals, and it's also the point on the x-axis. Okay? So the reason why we have 2 answers is because this parabola is crossing the x-axis twice. Do you think we could ever get, do you think there's ever a point where we'll have one value for x?
Yes.
Because what if it only hits the x-axis once? So if I do x squared, let me see, minus 8, I think it's plus 16. I might get that. Let me see graph. Look, how many times, I did it right, oh wow. Alright, how many times is that graph hitting the x-axis? So this one only has one solution. Got it? Do you think there'll ever be a point where there's no solutions?
Yes.
Yeah, if my parabola is up here, or if it's down here opening down. So it can also have no solution. But right now, ours is all gonna, there's one problem on your homework that has one solution. All the rest have 2, okay? Alright, that is it. We are done. Thank you for being a great class.